Hello students, in this video we will learn one more type of sensor, that is load cell. From this video the student will be able to understand what is load cell, its definition, construction and operating principle of load cell, different types of load cell and its working, advantages, disadvantages and applications of load cell. Now let us define what is load cell. Load cells are the transducers that convert applied force such as a weight into a differential electrical output voltage. A load cell is an electromechanical device which is used for the measurement of weights. It converts the weight or the force into an electrical signal. It is mostly used in the industrial applications for the static and dynamic force measurement. A load cell consists of a load receiving element, that is elastic element, with the high tensile strength as a primary transducer, and there is a strain gauges arranged in the bridge network as a secondary network. There are three different types of load cells, that is strain gauge load cell, hydraulic load cell and pneumatic load cell. Out of that, in this video we will learn strain gauge load cells. Now let us see its construction and operating principle. A load cell is based on the principle that the force applied to an elastic element produces a measurable deflection or the deformation. A load cell produces an electrical signal proportional to this deformation. The important part of the load cell is bounded foil strain gauge, which is an extremely sensitive device whose electrical resistance changes in direct proportion to the applied force. Load cell consists of an elastic element. This elastic element is made up of steel alloys, which are homogeneous materials. The basic design constraints are relative size and shape, density of material, modules of the elasticity, strain sensitivity and dynamic response. The elastic element used are designed and shaped according to the specific requirements. The elastic element of the different shapes are shown in this figure. Now see, there are the different types of strain gauge load cells. The first type is tension compression, that is column type load cell, and second is cantilever beam type of load cell. Now let us see the first type, that is tension compression or column type of load cell. This is a column type of load cell and this is a top view of the load cell. The four strain gauges are bounded to the load bearing column, such as the two strain gauges are in axial direction and two are in transverse direction. Look at this diagram. There are the four strain gauge. Two are connected, opposite strain gauge is connected vertically and remaining two are connected in horizontal direction. Now that four strain gauges are wired into the Western bridge circuit with the axial gauges in this first and third segment of the Western bridge circuit. Similarly, the transverse gauges or the horizontal strain gauges are connected in second and fourth arm of the Western bridge circuit. Now, when the no load is applied, the Western bridge circuit is balanced condition. That time output voltage will be 0. And when the load is applied to the load cell, the balance condition gets disturbed, and in response to the applied load, the differential output voltage proportional to the weight on the load cell is available at the output of this Western bridge circuit. Now the second type of the load cell, that is cantilever beam type. These are commonly employed for the measuring lower loads up to 10 kg. A simple cantilever beam serves as an elastic member. The two strain gauges on the top of the surface and the two strain gauges at the bottom of the surface are connected. The force is applied at the opposite of the fixed end. A bending moment proportional to the force is developed in the beam. The tensile strains developed on the top are sensed by the strain gauge 1 and 3, while compressive strains developed at the bottom are sensed by the strain gauge 2 and 4. This is a piston bridge circuit arrangement in which these two strain gauges are nothing but which are placed at the top, and these two strain gauges which are connected at the bottom of the cantilever beam. This is a column type of strain gauge load cell. Let us see its working now. This load cell is used for weighing extremely heavy loads. It uses the length of steel bar as an active element. It uses the strain gauges for the measuring weight. The weight is applied along the direction shown by this arrow. Due to this stress, the steel bar gets compressed along the axis, that is S, and it expands along the XY axis. Due to this, the resistance of strain gauge A will decreases, and whereas the strain gauge, the resistance, it will increase. Now in order to convert this change in the resistance into the voltage, the strain gauge we need to connect in piston bridge circuit. These two strain gauges and those on the two remaining sides of the strain gauge, that is column, are connected in the piston bridge circuit. This increases its sensitivity 4 times as compared to the single strain gauge. This arrangement will make the load cell very sensitive to very small value of the applied stress, and it can measure the very heavy load as well. Now let us see the advantages of load cell. The effect of temperature can be compensated using the bridge circuitry. Also, it is having a compact construction. There is no moving part and negligible deflection under load. It is highly accurate and wide load range. These load cells can be used for the static as well as dynamic type of loading. There are few disadvantages of this load cell. The mounting of strain gauge is very critical. Also, the calibration is very much complicated. Now see where these load cells are used. It is used basically in the measurement of force, pressure, displacement quantity. Also, it is used in the weight platforms for the dynamic and industrial purpose. It is also used in the process control system. So simply, the load cells are used for the measurement of weights.